Okay, let me say something about this question 12-13. And this is talking about the interaction between the operation of inverse and homomorphism. So let's take this step by step. First we have in Z8, 3 inverse equals 5. What does that mean? In Z8, 3 inverse equals 5. Now what does 3 inverse mean? This is referring to the inverse of 3 in Z8. Now what's the inverse of 3 in Z8? If we use our old notation, we would say that means we want to find an x such that 3 plus x, now this is the plus in Z8, equals x plus 3 equals the identity in Z8 is 0. All right? So that's what the inverse of 3 is in Z8. It's this value x. And you can verify that 5 works here. Why? Because 3 plus 5 with ordinary addition is 8, and then you take mod 8, you get 0. So x equals 8 gives me the result. So please be understanding here that this inverse is not multiplicative inverse, it's the inverse in Z8. So you need to be careful about where the inverses are applying. All right. Now the homomorphism G was, I'm going to have to go back and see what that was. I've pasted the picture of G down here. G maps elements of Z8 into the cyclic group generated by I in the complex numbers. This is cyclic group under multiplication. The operation here in this cyclic group here is multiplication. And the operation here, of course, is modular addition. Okay. All right, now, what question is being asked here? So in using this homomorphism, which is defined, mapping from Z8 to I, what is G of 3 inverse? What is G of 3 inverse? Now, 3 inverse was 5. So G of 5, here's my 5 here, G of 5 was I. So G of 3 inverse is equal to G of 5, which is equal to I. Okay, now, what is G of 3 inverse? Notice this is not asking for G inverse of 3. G inverse goes from the cyclic group generated by I back to Z8, but that's not what it's asking for. It's asking for the inverse element, G of 3 inverse is equal to the inverse of G of 3 in I. G of 3 is an element of the cyclic group generated by I. So I want the inverse of G of 3 in this cyclic group. Now, what's G of 3? Well, you follow here, here's 3. G of 3 goes to minus I. So I want to find the inverse of minus I. Find the inverse of minus I in the group here. All right. So you can go do your Cayley table. This is a multiplicative inverse, so because the operation here in this cyclic group is multiplication. And you'll find some relationship between the multiplicative inverse of minus I and this result here, the G of the additive inverse of 3. So notice what's going on here. We're taking the additive inverse of 3 and then applying G to it. Here we're taking G applied to 3 and then taking the multiplicative inverse. Right, so it seems that these operations are different, but you'll find a relationship between these two. And when you do these other problems here, you'll find similar relationship with other homomorphisms. So in fact, this is an instance of a general property. All right, so see what you can do with that.